Okay, let's now do the next lesson. This is called variation of parameters. Now, let's say we have a differential equation ay double prime as a second order linear differential equation ay double prime plus what? Plus by prime plus cy is f of x. Now, this f of x, okay, let's say our f of x is, let's say, secant of x. Now, in the table form, the method of undetermined coefficients, it's not possible to determine our y sub t or particular solution if f of x is secant x. So this time we will use variation of parameters. Okay. Now, if we let y1 and y2 be the solution of ay double prime plus by prime plus cy is 0, that means these are what? Parts of the complementary solution of the differential equation ay double prime plus by prime plus cy is f of x. Then, the particular solution now, based on the variation of parameters, will be yp is axy1 plus bxy2. Now, the difference here is that this, okay, this ax, right, this ax and bx are not constants, but they are variable functions of x. So here, ax and bx are functions of x. So they are variable. That's why this, okay, this topic is known as variation of parameters. We are now supposed to solve these two, ax and bx. Now, remember that since this is our yp, this should satisfy the differential equation, okay, ayp double prime plus byp prime plus cyp is f of x. In order for us to determine what are the values of a of x and b of x. Now, this is our yp based on this ax y1 plus bx y2. We need yp double prime. Okay, look at how we get the yp double prime. Remember that this is what? This is a and y1 as well as b and y2 are variables. You see, yp prime is a derivative of a product. It is ax, okay, times the derivative of y1, which is y1 prime, plus y1 times the derivative of a of x, which is a prime x, plus same b of x, okay, times the derivative of y2, which is y2 prime, plus y2 times the derivative of bx, which is b prime x. So observe that how, again, we get the derivative of a product here. It is ax times the first derivative of y1 plus y1 times the first derivative of ax. It's there. It's bx times the first derivative of y2. It's there. Plus y2 times the first derivative of bx is there. The next setup is collect all primes. So collect all primes associated with a and b and set them equal to 0. Now this will be our first equation. Okay, so we now have an equation for a prime and b prime. Okay, now get yp prime. Okay, so our yp prime, since we set this one, since we set what did you set to 0 in a prime x y1 and then what, and then b prime x y2, then the result will just be this one, axy, okay, axy1 prime plus bxy2 prime. Now we need to get the second derivative. Okay, the second derivative, this is again a derivative of a product, that is ax times y1 double prime, this one, plus y1 prime times first derivative of ax, this is a prime x, plus b of x times the second derivative of y2, that's y2 double prime, plus y2 prime times the first derivative of b of x, which is b prime x. Now remember that we will have to what? We will have to use this equation now. We will use this equation now to determine the values of, okay, to determine the values of a of x and b of x. Now, we're going to use this equation. We know already yp double prime, it's there. Okay, we know already yp prime, this is yp prime, remember that is yp prime. And our yp is what? Our yp is this one there. So, we substitute now. We substitute, we have a times what? A times the second derivative. This is the second derivative, which is axy1 double prime, okay, plus y1 prime a prime x. Okay, let's remove this. Let's remove this. Okay, plus this one bx times y2 double prime plus y2 prime times b prime x. This is what? This is yp. So this is yp double prime, and then this one is what? This one is yp, and then this one, rather, this one is yp prime, and this one is just yp. So that should be equal to what? That should be, I'm sorry, this should be equal to f of x, not 0. Okay, this should be equal to f of x. The next step is we collect all ax from here. What are these ax? So ax here is ay1 double prime, and then you have this one by1 prime is there, and then cy1 is there, and then collect all the bx. Okay, the bx is where? Here, bx there times that ay2 double prime, and then you have bx here times by2 prime, and then okay, b of x here is, you have cy2 there, that's cy2, and then collect all the a prime x. Okay, what's remaining is what? What's remaining is, okay, the a prime y1x is there, and then what? And then the b prime x y2, and that is equal to f of x. Now remember that y1 is the root of this differential equation, so it's a solution. Therefore, this must be what? This must be 0. Okay, this element must be 0 because y1 is a root. This must also be 0 because y2 is a root. So all is remaining is a prime x plus b prime x y2 prime equals f of x. So this remains, okay, a prime x y1 prime plus b prime x y2 prime equals f of x. Now we call this what? We call this equation 2. Let's summarize. We have equation 1 there and equation 2 there. So it's there. Equation 1, alright. This is actually our equation 1. And this is actually our equation 2. Next is, we solve this simultaneously. Use Cramer's rule. Okay. So look at the, what is a prime x here? Okay. A prime x is, okay, the denominator is just what? y1 prime, y2 prime, and then substitute what? Substitute 0 and this one, y1 prime, y2 prime is there, and then substitute 0 and f of x, and then you just have y2 and y2 prime. Then evaluate. Okay, this is what? Evaluate the determinant. This is there and there. So this is just 0 minus what? Minus y2 f of x, and this is y1 y2 prime minus y2 y1 prime. This is our a prime of x. Now if you know a prime of x, then you can integrate these to get a. At the same time, you have b prime x is here. You just write y1 and y1 prime there, and then there's 0 f of x. The denominator is the same. This is y1, y1 prime, y2, y2 prime. Evaluate just like, okay, just like there, that is this one, and then this one. You have what? y1 fx, okay, minus over what? y1, y2 prime minus y2, y1 prime. Now this denominator here, okay, this denominator there is what you call the Wronskian W. Okay, this is the Wronskian W, where your Wronskian is the same as y1, y2 prime minus y2, y1 prime. That is called the Wronskian. Wronskian. And then if you know what? If you know a prime and b prime, then you can integrate them and you can have the particular solution, which is the integral of this one and the integral of that one. Okay, let's have an example. Solve y double prime plus y is secant x. Okay, notice that the right side here is secant x. Now, if you use method of undetermined coefficients here, you cannot solve it, because method of undetermined coefficients is just limited to sine, cosine, e to the x, or polynomial function. So the first step is, of course, rewrite this in what? In d form or operator form. Okay, this is the same as what? D squared plus 1y secant x. Solve the equivalent auxiliary equation. Replace d by m. So you have m squared plus 1 is 0. The roots are m is plus minus I. And our complementary solution is c1 cosine x plus c2 sine x. Now observe that this now will be your y1, and this now will be your y2. Okay, so therefore that is your y1. y1 is cosine x and y2 is sine x. Will not matter whichever comes first here. Now your particular solution, okay, now get y1 prime first and y2 prime. Okay, we will use this later. Then your particular solution is what? Is ax cosine x plus bx sine x. Now notice that these a are functions, these b are these are functions of x, and remember this is your y1 and this is your y2. So basically your y particular is, okay, ay1, okay, ay1 plus by2, where a and b are what? Are variable functions of x. The next step is to get the Wronskian. Okay, the Wronskian can be found, okay, by what? Look at this y1 and y2. The Wronskian is the same as y1, y2 prime, that's the determinant, minus y2, y1 prime. So this is actually cosine x times cosine x minus sine x times negative sine x. Or look at this, cosine x times here, cosine x times cosine x minus sine x times negative sine x. This will give you cosine squared x plus sine squared x, each of course equal to 1. And therefore, your a prime of x, now you notice that your Wronskian here is already what? This Wronskian, alright, is already 1. And this is your a prime x. And to solve for a, you have to integrate. Okay, your a prime is negative tangent x. Sine over cosine, that is 1 over what? This is negative. That is 1 over cosine x. So sine over cosine is tangent with that negative sign there. So you have negative what? Tangent x. And integrate what? Integrate negative tangent x. That's negative ln of secant x And remember that this is the same as ln of 1 over secant x, and that is 1 over secant is the same as ln of cosine x. Now to get b of x, okay, from our formula, from b1 prime x is y1 f of x over the Wronskian. Okay, we just replace this by the Wronskian w. So this is cosine x times secant x, and cosine, of course, cosine x times secant x, this is 1 over cosine x, and therefore, okay, that is what? That is equal to 1. So this is equal to 1 over 1. So therefore, b prime of x is 1, and integrating 1, you have b of x is 1 dx is x. Alright, you know already what? You know already a of x, this is a of x, you know already b of x, and your particular solution is this one. Okay, a of x cosine x plus b of x sine x. Just plug a of x and b of x. Your a of x is ln of cosine x here times cosine x, and your b of x is x sine x. And your y is the sum of the complementary and particular solution. Okay, that gives you this one, c1 cosine x plus c2 sine x plus our particular solution here, which is what? ln of cosine x plus x sine of x. This is our general solution. Okay, let's have another example. Let's have d squared minus 3d plus 2y is 1 over 1 plus e to the minus x. Now, this is our f of x. Okay, solve for the roots of the auxiliary equation. M squared minus 3m plus 2 is 0. This is plugging d for m. You will have what? M minus 1 times m minus 2 equals 0. So the roots are what? The roots are 2 and 1, and the solution of the auxiliary equation is c1 e to the 2x plus c2 e to the x. Now notice that this is now our y1 and this is now our y2. Okay, so your y1 is e to the 2x and your y2 is e to the x, and your particular solution is ax y1 plus bx y2. Notice that these ax and bx are already functions of x, which are known. Okay, next is substitute this y1 and y2 in this equation. So we have substitute y1 and y2, and therefore yp is ax e to the 2x plus bx e to the x. Then get your y1 and y1 prime, y2 and y2 prime to solve for the Wronskian. The Wronskian is just the difference of the product of these two arrows. Your Wronskian is, okay, this one, e to the 2x times e to the x minus e to the x times e to the 2x. Observe our formula. Observe our formula of our Wronskian is the same as y1 y2 prime minus y2 y1 prime. So it's easier for us to, okay, understand, okay, remember this formula by using this this technique. So your wx is what? Your wx is e to the 2x e to the x minus e to the x times 2 e to the 2x. Okay, this is of course the same as e to the 3x minus 2 e to the 3x. So your Wronskian is what? Is negative e to the 3x. Now you can solve now for a and b. Okay, remember our formula, a prime x. Okay, this now is our formula where the denominator is w, which we know it already. Therefore, your a of x, okay, is the integral of, okay, this is our what? This is our y2. Of course, this is our what? This is our f of x, and this is our Wronskian. Okay, so simplify this. Okay, this is the same as e to the x divided by negative e to the 3x, that's e to the negative 2x. Okay, times 1 over 1 plus e to the minus x. Now, this can be written as, okay, because the degree of the numerator is bigger than the degree of the denominator, we have to use this technique. Okay, factor e to the negative x, then that is 1 plus e to the minus x. Notice that this is the same as e to the negative x plus e to the negative 2x. Okay, and then you have to subtract what? E to the negative x. So basically this is the same. Okay, this is the same as, alright, this numerator is just the same as e to the negative 2x. Okay, so divide, you see, you can divide this. You can divide this will cancel out. Okay, so you'll see this is the same as just e to the negative x minus e to the x integral of e to the negative x over 1 plus e to the minus x. Now this is easy. This is just negative e to the negative x. Now this one, how do you integrate this? If you let u is 1 plus e to the negative x, then du is what? Negative e to the negative x dx. So this will just become du over u, and therefore the integral, okay, is negative e to the negative x plus ln of 1 plus e to the negative x. Now to get b of x, your b of x is what? Okay, your b of x is okay, so your b of x is, remember this formula now, y1, okay, f of x, b prime is y1 f of x over y2 minus this is the same as w, the Wronskian, and plugging this y1, your y1 is, remember this is your y1, that is your y1 there, e to the 2x y1, this is your f of x here, and this is your Wronskian. So basically this is your what? y1 in the y1, this is your f of x, and this is your w. So simplifying, this is integral of negative e to the negative x over 1 plus e to the minus x dx. And you see, again, if you let what? If you let u equals 1 plus e to the negative x, then your du is what? Negative e to the negative x dx. So this is just du over u. So this is just ln of 1 plus e to the minus x. So you know already what? You know already, b of x, you know already b of x, and you know already what, a of x. So where do we plug? We plug in this equation yp. So we know already yp. Our yp is what, ax y1 plus bx y2. Plugging that value, this is our yp already. Next step is here. Our yp is negative what, negative e to the negative x plus ln of 1 plus e to the minus x e to the 2x plus ln of 1 plus e to the minus x times e to the x. And your y is the same as y sub c plus y sub p. Therefore your y is this is our y sub c there, c1 e to 2x plus c2 e to the negative x plus negative e to the minus x plus ln of 1 plus e to the minus x times e to the 2x plus ln of 1 plus e to the minus x times e to the x. Now notice that this negative e to the minus x times e to the 2x combines only to what, e to the combines to what, combines to negative e to the x. This one, when multiplied there, it will just combine with c2 e to the x. That's why I put c2 prime here. So that is y equals c1 e to the 2x plus c2 prime e to the x plus ln of 1 plus e to the minus x e to the 2x plus ln of 1 plus e to the minus x e to the x, which is our what? Which is our particular, rather general solution.